Hello everyone, I'm Official Sando. Today we'll go through a real coding interview question, print folder structure. If you like my videos, you can support me by subscribing my channel or click likes of the video. You can find code of these examples and all of my video links in video description below. Alright, so the problem is pretty straightforward. We are given a vector of strings, and each strings presents a path to the file and separated by the backslash. Then the requirement is to print a more like typical folder structures in the system. For all of the parent folders need to have like two space leading, then it's child folder. For example, let's look at app lib header file.h. It presents as app double space lib and header here and the file.h here. So the total print output it will be combination all the paths in the input. You can pause here to think about how you would solve this problem. All right. So when I do these problems, I really cannot think of a brute force method for this. I think I just come out straight what kind of the most optimal solution as I can think of. So my solution is more like build a try tree and then do pre-order traversal for printing such result. I think when you prepare for this type of interview, you may need to feel familiar when you see this kind of structure. It's more like tree structure. So I think, yeah, it's may like if you did these problems offline, so you may able to do that on the interview. Otherwise, it's so hard to come out directly for this pattern. Right, then let's see how we use try tree to solve this problem. And to first, we need to build a try tree. We need a try node represented by struct. The try structures contain two parts. One part is the mapping the string to its child node, and also itself's name. Here I use map because I want to put the lawyer's characters string at first. So I want to let this sorted. We can initialize try by take the input. We also need to provide the interface to add child. If the value is already in the child, we just directly return it. Otherwise, we instance a new child node here. Apart from the try struct, we need to create a file system class to solve the problems. Then to initialize the file system, it's just the process of build a try tree. We take a vector of the string of files. Then we iterate all the file. Then for each file, we need to basically separate each word based on the backslash. In C++, it's kind of tricky to do that. Though you can use some like off-strings library, but I show here like how I do that in the Scratch. Then if you do this in Python, you may have an easy way to handle this the segmentation. Let me go through one examples to show how this for loop to process the one file. For example, we start with app lib header file.h separated by the backslash. Then I have a temporary variable here to store the trunk of the string. Then every time I see a backslash, I will do something differently. So if I start with the first backslash, I'm going this here. because here is still empty, I won't do anything in this if loop. So I just directly add in the backslash here. So next, I'm visiting A here. A is not slash, and A is also not the end of the string. So I'm going to these options, just appending the A into the trunk. Then eventually we have backslash APP. Then we hit the second slash. Then in the second backslash, because the current phone name is no longer empty, so I'm going to visit my current node and add the child to using the current folder name. So first I have a now in the root, then I will add app in its parent node. Then we do this sequentially till the last character of the string. Since previously, like when we see a backslash, we will add its previous word into the string. However, foo.h don't have another backslash, so we will do this special handling for the last characters to add the final child. Then eventually we have now app lib header foo.h tree. Then continue to process to the second file. I'm not going to the completely the whole path, but one thing I want you to pay attention is that here, when we have the lib here, what we really see is whether app is already have the lib child folder. If not, of course we create a new one. But if it does, it just directly return the existing child. So this is happening in line 20 here. Then eventually at lib, we'll create another child for CPP folder. Then this is the complete tree after we process in the second file. Then eventually we will have this complete tree built. Then we need to print in the output. We'll have the print folder structure in the file system class. It directly call this pre-order traversal, and in this function it will recursively call itself. Let's see how it's implemented. We are passing a global variable here. Basically this just I think it's a typo here, so it's not tab, it should be space. Then it will continue adding two space when we go into the next level of the tree. It works like following. First, we are printing out the root. Root will be empty. Then we add in two space, and we are printing the first node is app. So we'll see space app. Then app, we have for loop here to visit its all children. But remember, this is a pre-order traversal. We will always visit the left one. So left one is lib here. Then we recursively call this pre-order traversal. We are printing lib. Lib, it also has two leading space. Then lib has two child. We will visit the CPP actually here. I think I do a mess up the order because first time we use a map. The CPP will be ordered in the first. So we will say like, yeah, to kind of comply my current printing, say, assuming the first child is header, then we are printing header with 6 space, right? Then foo.h with 8 space. Then foo.h doesn't have any child. We will get back to header, pre-order traversal. Then to see whether it does have other childs. Right now, it does have. So we continue with snake.h. One thing to remember is that foo.h and snake.h will have same leading space, right? Because start from the header. We'll print snake.h, then get back to header. At right time, headers all children has been visited. So we will get back to lib, then to CPP. So what we will see here, the CPP have 2 less space than the last print snake.h. Then eventually we continue printing all of the trees. you will see the result as the requirements of the problem. I didn't do a performance complexity computation and for space as well, because I'm thinking this is not really, the problem is not really aiming at to testing your complexity analysis. I do believe the space complexity is bigger of n. N is how many words we have here. I'm not too sure about the computation complexity. So you can take a look for the website to see what's the correct one for the tri-tree. All right, so hopefully this video help understanding how you use a tri-tree structure to deal with this kind of problem. Feel free to add a comment and a question. Otherwise, I'll see you in the next video. Bye bye.